Here we're asked to sketch the graph for the function and find the area under the curve between 1 and 5. And we're using 4 right endpoint rectangles for the function f of x equals 1/2 x squared. Then we'll write the sigma notation at the end. Okay, so to start, I'm going to go ahead and draw my graph here. And I'm going to find the width first. That's usually my favorite thing to deal with because it'll help me with my graph. So since I'm going from 1 to 5 here, I know I'm going 4 total units divided up 4 ways because I'm doing 4 right endpoint rectangles. 4 over 4 is just 1. Okay, this one will be nice and easy to graph because when I'm going through this, I am just going to be going up by 1 each time, which is good. So on my graph here, I'm going 1, 2, 3, 4, and 5. And I'm looking for the area between 1 and 5 here. Now I'm going to use X and Y table here to help me plot those points. So I'm going to plug in 1 through 5, and I get a couple of different numbers here. So 1, 2, 3, 4, 5. 1 squared is 1 times 1/2 is 1/2. 2 squared is 4 times 1/2 is 2. 3 squared is 9 times 1/2 is 4.5. 4 squared is 16 divided by 2 is 8. 5 squared is 25 times 1/2 is 12.5. So now I'm going to plot these points on my graph. All right, so for this one, it's not a straight line, it's a quadratic. So it should give us this kind of, right side of the U there. And we have our graph that we're going to be dealing with. So in this case, we're going from 1 to 5. And I next need to actually draw my rectangles. My rectangles here are 4 right endpoint, meaning I'm going to use the right side as the one that actually touches the graph. So on my first rectangle here, you see I don't actually use this left point here, this left x value or the left y value. I'm using the height here at 2. Then I go from the right side of the rectangle that touches it, the right side, and the right side. So what we see here is 4 rectangles now, where each of the rectangles, the right side of them, are what touch the actual green line or our function that we're dealing with. So from there, now we are going to look for the heights of all of those. I'm going to go ahead and just point them out. You already have them because really it's just these y values here. I'm just going to point them out so that everyone can see where they're coming from and to make sure that you understand that this is why it differs if we're using left endpoint versus right endpoint. So there's all of my heights. So to find the area of each of them and adding them together, I'm just taking the width times the height. My width is 1. My height, there's 4 different ones, so I'll write those all out and calculate. In the end, you should get 27 units squared for my area. Just double check and make sure that you're only using, 4 different numbers after we've multiplied those lengths and widths because we have 4 rectangles. Okay, from there, I have not done anything during this problem to help me with sigma notation, so I'm going to go back and do a couple of things. First of all, I'm going to label all of my x values in subscript notation. And then I'm going to create an x sub k table. So I'm going, my k value is 1, 2, 3, and 4. I am not using 0 here, again, because we're not using that height. So just so we know, we're not going to use that in sigma notation. Now, x of k values are just, what do we got? 1, 2, 3, 4, and 5, because I'm looking at all the x values here. Now, if I'm coming up with an equation for this, I'm going up by 1 each time. So x of k equals 1 times k, which I'm just going to call k. And then when k is 0, x of k is 1. So there's my function for x of k. Okay, sigma notation, here we go. 3 pieces, I take it 3 pieces at a time, or I guess 1 step at a time, 3 pieces. starting with k, what I realize here is that I'm using all the right sides, meaning I'm using the k values from 1 to 4 because of these little subscripts here. That's where I get my numbers on the top and the bottom of sigma. Now, the insides are going to just be the height times the width. I don't know why I switched that around. I usually do width and then height. That's my bad. And so I know the width every time is going to be 1 because I calculated it up here. So now I'm going to rewrite closer to my final answer. I'm doing the width first here. Please don't be mad at me. Now the height I'm going to get from an equation, from the original equation that I was given up here from the very beginning, because the heights are always my y values of that original function. So I am going to rewrite my original function here as 1/2 and then x squared, but instead of x, I'm using x sub k because I'm using different x values each time. And so my final answer here, all I have to do is take what I have and plug in x of k where you see that blue piece. So I'm still going from 1 to 4. My width is 1. My height is 1/2 times my x sub k, which is k plus 1. And then that is squared. So again, I'm just taking x plus 1, plugging it in for x of k here, and then that gives me my final sigma notation. So my area under the curve, my approximate, and the equation or the sigma notation that represents that area.